Okay, so we're working on activity 1.1.6. We're going to start with number 1, combinational logic, and we have to build this circuit that has the 74LS04 AND gate. We already know this is an inverter gate, and remember, since we're in digital, we need to use DGND for our ground and VCC for our power. And then we're also going to have to add a switch and then complete the truth table once we make the circuit. So first thing we always do, remember, we go to File, Save As, and we make sure we have this saved as activity 1.1.6. I already have mine made, so I'm just going to press cancel. I already set it up. So now we're going to go to Place, Component, and under Sources, we're going to go to, sorry, I'm under Basic. Under Sources, go to Power Sources, and then we need VCC for our power. Click OK, place it anywhere, and then we need DGND. And place it under here. And then we need a switch, so we go to Basic, Switch, SPDT, remember, single pole, double throw, it says it right there, and then it has a picture right here. You can always make sure that the picture matches with what you want. Press OK, and we place it right here. And then we're going to get the inverter gate, so we go under TTL. 74LS is a family we need, and then we find 74LS, and they go in order, 04N. Check the picture, yep, that's an inverter gate. It even says it here, hex inverter, and we press OK. Now every time we add a new piece, it's going to give us this option A, B, C, D, E, F. For now it doesn't matter. When we make more complicated circuits, you'll see why, but for now let's just click on A and place it here, and then we can cancel. Next we need the probes, right? So the probes are going to be in the same place our ammeter and voltmeter are. If your taskbar, for some reason, if you're using a different computer or if it didn't save, that's under View, and you go to Toolbars, and it's Measurement Components. Okay, so make sure you have that active. And the probes are just these basically colored LEDs. I'm going to make the input probe be blue and the output probe be green. And what I'm going to do is this switch, we need to have both of these side, both of the inputs on one side and the output on the other. So I'm going to right click. I'm going to do flip horizontal and flip vertical. Where is it? I think I didn't. Right click, flip vertical. Now it looks like the picture. See that? You may be wondering, yours probably says like key equals space, and it has some letters, and here it says 5 volts VCC. So if we actually right click and we go to properties, display, my default, this is my personal computer, so my defaults are already set to the way I want them, but these are the settings I have right now. So if you want yours to look like that, you can. And then when you click it, it'll show up. You can turn off any labels, it doesn't matter, but I'll put them on for you guys. Okay, then we're gonna take this and we're gonna connect power to the top and ground to the bottom. And then we're gonna connect the output to the inverter gate and the inverter gate to the probe. I like to make everything line up so it looks neat. And then we're gonna place the probe here. So I can just click the switch and it will change. So when I have it this way, that means power is going to here, and then when it goes to the inverter gate, it should output a 0. So let's play. See, when this is a 1, output is a 0. So I'm gonna go ahead and put that on my truth table. When this is a 1, output is 0. And then when I try input is a 0, my output is a 1. So we can fill that in. Okay. Now the second one, this one's more complicated. What we're gonna do, still start with the 5 volt and the ground. It looks like we need 2 switches this time. We know this is an AND gate, so it's O8N, and it looks like we need 1, 2, 3 probes. So I'm just gonna move, remember you click on the wheel and you can drag this down so I can go to my space. If you don't have enough space like me, mine's on some weird option. We're gonna go to sheet properties. And then remember I said under workspace, good rule of thumb, 20 for the width, 20 for the height. They seems to have been working for our class, so we'll just keep going with that. And then place, component. Oh, see how it's gray like this? I'm glad I did this. See how I can't select that? What do you think that is? It's because we still have the simulation running. Okay, so if you look at the toolbar, see how this is blinking? That tells you it's still playing. So you can also just press stop. Now I can go to place, component. You can never edit your circuit when it's on. Sources, power sources, we need a ground. We need a VCC. We need 2 switches. Under basic, switch, SPDT. Okay, and then this time the gate we need under TTL is 74LS08N, which is an AND gate, quad 2 input AND. Press OK. Let's click A. There you go. Cancel, exit out. And then we need 3 probes. So I'm gonna do, I don't know, yellow. And do green. And we'll do red. Actually, I don't like this yellow. I feel like it's hard to see, so I'm gonna delete it and put a blue one instead. Okay, again, for the switches, right click, flip horizontal, flip vertical. Flip horizontal, flip vertical. I'm gonna drag these so they're more in line. I'm gonna move my ground down a little bit. You'll see why in a moment. Okay, I'm gonna hook up the power to the top of the switches. And this time, because they overlap, I'm gonna right click, properties, and I'm gonna make it red. Okay. Okay. Now I'm gonna hook up my ground to the bottom switches. And I didn't make it in line with the power, so it offsets, because otherwise if they're all stacked, it's really hard to see the wires, so there's a little offset. And I'm gonna go to properties, net color, and I'm gonna change it to black. Remember, power is always red, black is always ground, so it's good to just go with that convention. Now the output of the switches, the top one's gonna go to the top of the AND gate, the bottom's gonna go to the bottom of the AND gate. And I like to move the top of the AND gate up with the top line. Let's move these probes. It's always some like moving around you have to do with Multisim. And then I like to move it like that so they're parallel lines. And then I'm gonna click this, move it over here. And I'm gonna connect the probe to the output of the AND gate. And then this is important, you're gonna move the top probe, let's move it up a little bit, is only gonna have contact with this output. And the second probe is going to connect to the Y. It looks like it's connected to both in parallel, but it's not, and I'll prove to you that. If you right click on properties, we can change this to, let's make it a light blue. And now you can see this wire doesn't attach to that one at all. And then let's make it look more like this picture. See how it says X, Y, and Z? What we can do is we can go Right-click Properties. And under Label, we can just change it to X. Right-click Properties. Make sure that you have Show Labels on, or Show Ref does, I'm pretty sure. Properties, Label, let's change this one to Y. Display, show everything, okay. And then we can make this one Z. Okay, I was confused because I was like, why are these not? I thought they were white, but we're good. So when you have the power hooked up to the first part of the AND gate for both of them, both of our inputs, I don't know why this one's not lighting up. We're gonna delete this. This isn't working right. Let's put a new blue probe. Okay. Properties. So it wasn't lit up. I don't know why. I don't know if I did something wrong. But you can always just, whenever something doesn't look right, you can always, I always just delete it and redo it. Okay, so this is an AND gate, and we have our truth table. So let's go through the truth table. Let's make X and Y 0 and see what the output for Z is. So in order for it to be 0, we put them both on ground. So this confirms X is 0, Y is 0, and our output Z is 0. So we're gonna go write that in our truth table. Now we're gonna try X0, Y1. X0, Y1. There we go, Z output 0. We already know this, but just confirming our circuit works. And now we're gonna do X1, Y0. Let's press stop. See, X is doing a funny thing. It should be lit up. X1. But Z output is 0. And then when we have them both on 1, Z is lit up. So Z is 1. Then I want you to answer from the analysis of the truth table, why do you think this is called an AND gate? And then I'll just show you real quick number 3. So number 3 looks like the same exact circuit, and we even have the same truth table. But don't be fooled, there's this little circle right here. See that? It's not just an AND gate, it's got a little circle. And it says 0, 0, N. So this is a gate we haven't used before. So we have to make a new circuit and test it and try to figure out what the truth table is. So one shortcut you can do is you can just actually highlight the whole thing. Right click, up, again, press stop. Right click, copy. You guys are gonna hate this if you've done this before and didn't realize the shortcut. And then you can just paste the entire circuit. Oh, I got the ground from the circuit. So I want to delete this one because that must have been from the circuit above it. Now I'm just going to delete this AND gate. The wires go away. And I'm going to go ahead and go to Place, Component, and I want the 0, 0, N. This mystery gate, we don't know what it does. Press OK. I'm going to place it here. B, whatever. Oh, never mind, I don't need that. You can right click it and it will go away. All right, connect the top to this wire. Actually, you know what? I like to just redraw the wires all together because they get really weird when you paste them. So I'm gonna delete this and delete this. All right. Output of this switch goes to the top of the gate. Output of this switch goes to the second input of the gate. First probe goes with this one. Second probe goes with that one. Output goes with this probe. All right, so we're gonna go through the truth table. First one, remember, 0, 0. Just press play. When both of them are 0, Z is actually 1, which is really strange. So we know this isn't an AND gate, because if you have 2 zeros as an input, Z should be 0. So we're gonna go ahead and put that in our truth table. Z, Z, 1. Now we're gonna try 0, 1. X is off, Y is on, and Z is on again. Strange. So we're just gonna put that in the truth table. Now we're gonna reverse them. So X is on, Y is off, and Z is on again. So we're gonna give it a 1. Okay, the last one, both of them are on. Oh, and Z's off. So this table, if you look, is actually the opposite of number 2, right? We had 0, 0, 0, 1, and now we have 1, 1, 1, 0. This is called a NAND gate. And basically what it does is it takes the AND function and then it outputs the opposite of what the AND function would. Don't worry, we're going to learn about this later, but I'm just trying to show you that just because this looks like an AND gate doesn't mean it is an AND gate. You have to pay attention to each number. So for this one, you know this one is a OR gate, but there's other ones you have to make sure you put the correct number in and really follow the truth table because some of them might not go the way you expect. So again, here's the completed circuit for number 3, and good luck.